So Alfred Wegener. So let's study volcanoes. We'll be finishing it today anyhow. 29. So energy plus force. So there are different types of force or the energy. The continental force, the endogenetic and the exogenetic forces. So endogenetic forces refers to catastrophic sudden events like volcanoes and earthquake, and it also refers to slow forces, also known as diastrophic forces. That is, diastrophic forces are of two types: horizontal, vertical. Horizontal is like two continental plate converging with each other that leads to the formation of mountains. But if two oceanic plate and the continental plate converge, it can lead to the formation of block mountains. And if two oceanic plate converge with each other, then it can lead to the formation of islands due to volcanic eruption. So endogenetic forces, exogenetic forces. Endogenetic, exogenetic forces after volcanism, that is sun's energy. Okay, it's exterior. And what are the endogenetic forces? Catastrophic and slow forces. Catastrophic is like sudden forces, right? Volcanoes and earthquake. And slow forces is diastrophic. Catastrophic, that is can be horizontal and vertical. So horizontal. This is the formation of mountains, that is also known as orogenic forces. And mountain building forces, horizontal force builds mountain. And then we have the vertical forces, that is epirogenic forces. So vertical forces will build continent actually. So we'll see this. Orogenic forces are further divided into push into the point, that is compressional force, and pushing away from the point, that is a tensional force. Okay. And epirogenic, that is a vertical force, and I have to check it again. So energy plus force factors affecting the interior of the earth. So endogenetic, exogenetic. Exogenetic is outside the earth, that is the sun. And endogenetic, there are two types of endogenetic forces, that is a catastrophic forces and a diastrophic. And catastrophic is sudden movement, certain forces like volcanoes and earthquakes. And diastrophic is horizontal and vertical. Okay. Endogenetic, exogenetic. Okay. Catastrophic, slow forces. Okay. We are not interested in exogenetic right now, so we are more interested in endogenetic forces. Catastrophic and slow forces, right? That is, catastrophic is sudden, diastrophic is slow forces. So diastrophic can be further classified into horizontal and vertical. So horizontal is orogenic, mountain building forces, and vertical is known as epirogenic, that is continental building forces. Okay. Catastrophic, diastrophic, slow forces. I'm more concerned about slow forces, that is horizontal, vertical. Horizontal is like convergence of the two plates, that is the mountain building forces, what we call as a block mountain. Okay. And the vertical is the epirogenic, that is a continental building forces, that is okay. Vertical forces building continent. Okay. So orogenic forces are further divided into this orogenic forces, that is the mountain building forces, are further divided into, and epirogenic forces will be further divided into. So these orogenic forces are further divided into push into, that is the compressional force, push into, and push away. Okay. So what we call as convergence and divergence. Push into the forces, that is the compression force. Compression force, what it will create? Of course, is going to create fold or the fault mountains, like the rift valleys and the block mountain as well. Then we have what ground doesn't break upward or downward, dependency on where the work is happening. It is a slow force. When you apply more force on warp, it will create a fold, right? Create a fold or downfold. Upfold is called anticline, and downfold is called syncline. This is one of the fold portion of not warp. Okay. So okay. Endogenetic, exogenetic, endogenetic, catastrophic, diastrophic. Diastrophic forces is further as you know these words. catastrophic, diastrophic. So diastrophic, horizontal, vertical, horizontal, orogenic, epiorogenic. Orogenic further divided into compressional forces and push away, like convergence and divergence, right? Tensional forces, that is compressional forces and tensional forces. Push into the point, that is and this compressional force will create fold or the fault mountain or warp, that can be upward warp or the downward warp dependency on where the warp is happening. It is slow force. When you apply more force on a warp, it will create a fold. So yeah, and it the upward part is called the upfold and downward part is called the downfold. The upward part of the fold is called the anticline and the downward part is called syncline. This is one of the fold portion. Okay. Then we have push away, that is from the 23 minutes away. Push away, that is from the point, that is a tensional force. Compressional, tension, compression, fold, fault and warp. ठीक है, जैसे जैसे क्रिएट होगा तो अपवर्ड और डाउनवर्ड वॉर्प क्रिएट होगा. अपवर्ड वाला जो होगा उसको एंटीक्लाइन बोलेंगे, डाउनवर्ड वाला सिंक्लाइन बोलेंगे. डन. पुश अवे फ्रॉम द पॉइंट इज अ टेंशन फोर्स. ओके. When you pull something out, something, it can create a fault. So if two plates are diverging, so it can lead to compressional fault or the tensional fault. Epiorogenic forces. Epiorogenic is related to continent, also known as continental building forces. Vertical forces, continental building forces, upward force uplift and downward force subsidence. So when the force is applied in the upward direction, it can lead to uplift of the mountain, and in downward force subsidence. Okay. Now moving towards Earth surface movement and related, the first person to talk about the Earth. Moving toward the theory of the formation of the continents, Alfred Wenger. So the continental drift theory. So we are talking here about the continental crust and the oceanic crust, how the continents were formed, the jigsaw puzzle and the concept of jigsaw puzzle and all. And moving towards the volcanoes and the volcanic eruptions. So Alfred Wenger was studying climatic properties of Earth. Fortunately, he discovered the continental drift theory. So this guy, Alfred Wenger, he was studying the climatic properties of the Earth. So while studying climatic properties of the Earth, he found that in the hotter regions, the particles of the glaciers were found. So he was confused, how come in the hotter region the particles of the glaciers, eroded glaciers could be found. So therein he suggested that that the continents has moved away or into the presence of the sunlight. So therein he suggested that the continent is moving. So the continent right now, which is there in hotter region, was some years before in colder region, and the continent that was in colder region was some years before in hotter region. So he speculated that I am fine. अभी थोड़ा मुझे I have to study Ronnie, okay, because I have to study. Okay. So he speculated that the continent that was in hotter regions some years before was in colder regions, and the continent that was in colder regions was in hotter region. But how can this be possible? It was sure that the sun is not moving, the sun is at the fixed point. Then how come there is a climatic changes and the glacier deposits are found in hotter region? So that's where he speculated. Thank you so much, Ronnie. That's where he speculated that the continent has moved away from each other. So it's not the sun, but there is some issue with the continent. So that's how he speculated continental drift theory. So Alfred Wenger was studying climatic properties of Earth. Fortunately, he discovered the continental drift theory. So how did he discover? He created the concept of the jigsaw puzzle. If you break the continent, it's like a jigsaw. The continent is like a jigsaw puzzle. As you can see, if you break this continent and try to fit in into other part, then it get fit. It gets fitted is easily like the jigsaw puzzle. So that's why he speculated that the continent has broke away from each other and has joined to some other parts. So according to him, earlier there was a full continent, Pangaea and Panthalassa. We'll see this, and a single ocean. So jigsaw puzzle, the content fits like the jigsaw puzzle, which means earlier they were together. So the continent fits, they will fits like jigsaw puzzle. So he speculated that earlier the continent was together. So when we say continent, we are talking about the continental crust, of course. Okay. So first person to talk about the continent being together, Abraham Ortles, and the theory was given by Alfred Wegener. So what was the observation of Wegener? So Wegener set out to study climatic condition of different regions. Wegener set out to study the climatic condition of different regions in different parts of the world. He found that in places which was in colder region, the climate in the past was hot, and the places which were in hotter region, the climate in the past was cold. So there are two possible explanations for this observation, I would say. That is, the climatic region would have changed, or the continents would have shifted. So it was not possible for the climatic region to change because the sun is fixed at one point. So most possibly the continents would have shifted. But the reason he gave for the shifting of the continent was wrong at that time. The climatic region did not shift because Earth's orientation, the tilt of the Earth has to vary, which is not the case. Continents of the Earth is moving or is moved. Now, what are the evidence for this? The continent seems to be, first evidence is that the continent seems to be fit together like that of the jigsaw puzzle, as said by Abraham Ortles. And we'll see Weber observation. Around 250 million years ago from present, all the continents were joined together and formed the big supercontinent called the Pangaea, and surrounded by a super ocean that is known as Panthalassa. Right now we have Atlantic Ocean, Pacific Ocean, but all this has evolved with time period. So it was mainly 250 million years ago. So all the continents joined together and formed the big supercontinent called the Pangaea, and surrounded by the Panthalassa. So Pangaea is a supercontinent, and Panthalassa is a super ocean that surrounds the Pangaea. So earlier the Earth, the continent were fixed together; they were not separated, or what we say as joined together. So around 250 million ago, the Pangaea started to break. Now the continent will start break around 250 million ago. They started to break, but how did it happen? The force that he gave for the breaking of the continent is wrong, because again it was discovered by some other scientists and geographers. So around 250 million ago, the Pangaea started to break northern part and the southern part. Okay. So now this the supercontinent, the Pangaea, will start to break towards the northern part and into the northern part and the southern part. So northern part he called as Laurasia, and the southern part as Gondwana, what we hear today as Gondwana land, named after Gonds in India. Gonds are the oldest tribe. Breakdown created new sea called the Tethys Sea. So earlier it was Pangaea Panthalassa बना दो आप, Pangaea Panthalassa. Then what happened? $250 million years ago, right? Yes. Pangaea Panthalassa, and then formed in the Pangaea broke into northern and the southern part, and the northern part was called Laurasia, and the southern part as the Gondwana land. So we from this to this, Laurasia, northern, that is the Tethys Sea here, and the southern there is the Gondwana land, and there is the equator. On supercontinent, Valvera, Rhodania, Pannotia. Okay. Triassic period, 145 million years, 2.5 million years ago. The Gondwana land also started to break and led to the formation of South America. So now this Gondwana land will also start to break and it will lead to the formation of the South America, Africa, Indian subcontinent. That's how southern continents were formed from Gondwana land. South America, Africa. So earlier there was Pangea, Panthalassa supercontinent, and then it started to break and to form South America, Africa, Indian continent, Australia, Antarctica. And led to the formation of South America, Africa and Indian subcontinent, Australia, Antarctica. ये पूरा साउथ वाले में आ जाता है. ठीक है. Eurasia, Gondwana land, Gondwana is South America, Africa, Indian subcontinent, Australia, Antarctica. So in the fourth step, the continent further moved northward, and some of the continents on the western edge started moving westwards. Further moved northward. Okay. So in the fourth step, the continent further moved northward. 13 minutes. And some of the continents on the western part started moving westward, like North America and South America. Okay. In the last step, the continent is of present day. He said that the continent is floating over the ocean floor. This is not right. So how the continent is moving? Is the parts of the continent floating on the ocean floor? No, not ocean water. It says that the continent is floating over the ocean floor, and मतलब oceans के अंदर. I mean continental crust are floating on the oceanic crust. This was a wrong part of his observation. The evidence. So what are the evidence? Jigsaw tilt, that is jigsaw tilt, rocks type. What are the evidence? That is you can see the continent can fit together into each other. That is jigsaw tilt of the continent. Rock type. Rocks found in Africa and South America are of similar nature, and the deposit are not older than Jurassic period. 12 minutes. So rock type. Rocks found in Africa and the South America are similar. Straight. Okay. So rock found in the Africa and the South America are of similar nature, and the deposit are not older than Jurassic period. Jigsaw tilt of the earth. Rock type. So northern, southern. The southern continent, that is Gondwana land, formed into, further broke, and it formed into South America, Africa, and क्या क्या था यार, South America, Africa, Australia, Indian subcontinent, right? And the continent for the fourth set, the continent further moves northward, and the some continent, the western part also further moved westward, which led to the formation of North America and South America. Yes. So evidence jigs of the rocks found in Africa and South America are of similar nature, and deposits are not older than Jurassic period. Third is a fossil remains deposit. Okay. First, the fossil remains deposit, then placer deposit. Fossil remains deposit, the animals, the same fossils has been found in same south in Africa and America. Placer deposit due to moving water, minerals which is eroded and deposited in the surface. Other place also placer deposit has been found. So jigsaw tilt, then fossil deposit, then placer deposit, rocks type. क्या क्या jigsaw tilt, rocks type, fossil deposit of the animals of the Jurassic period, placer deposits. In Africa, gold west was the reason where placer deposit was found, but the source was not to be found. So in South America, on the Brazilian coast, there are gold mines. Yes. So this is a perfect example. So in Africa, gold west was was found, but the source was not found. But the source was
Idea. I got an idea how to get out, but वो idea के लिए छोड़ो. क्या?
दिखेगा
नहीं.
It's okay. चले. नहीं.
नहीं दिखेगा.
खड़ा हुआ है
Mama, can you see me?
No.
किधर दिखाऊंगा मैं? अच्छा. जल्दी कैसे start? Sister, हाँ.
So jigsaw, okay. So jigsaw tilt, rock types, fossil fuel of the animals, and the placer deposits. So in Africa, gold vase was found, but the source was nowhere traced. Then it was then in South America, gold mines was present. In South America on Brazilian coast, gold mines are there. And glacier deposit of the glaciers, hot region had glaciers. Remains of the glaciers in hot region, remains of the glaciers was glacier till ice were found. So deposit of the glacier hot region, glacier till ice were found, for example in Madagascar, Parkland and Indian subcontinent. Example क्या है? Madagascar, Parkland and Indian subcontinent. Okay. Paleomagnetic evidence. So when the continents were joined in the distance past, the magnetic material pointed. Now this is another evidence. Paleomagnetic evidence. When the continents were joined with each other. So when the continents were joined in the distant past, the magnetic material pointed in a direction of the then magnetic field, and it solidified. Magnetic force, magnetic field, volcanoes and all. Okay. So when the continents were joined in the distant past, the magnetic material pointed to the direction of the then magnetic field, and it solidified. In the present time, due to continental displacement, those magnetic field of magma point in different direction. What forces led to this movement? So he explained all the observation, gave the evidence, but when talked about the forces, what led to this movement, he was wrong actually. Wegener was not prepared for this. He said when the Earth was rotating, the continent tried to come up against the gravity, okay, centrifugal force, and they moved away from the poles, called as the polar fling force. So the force he used as polar fling force, okay, or gravitational force. He did not use centrifugal force. Why continents are moving westward? As the Earth rotates from west to east, the bulge will move east to west. As tides are moving westward, it moves the continent also westward, because the tide is strong enough to move the continent westward. So एक तो बोला सेंट्रीफ्यूगल फोर्स, दूसरा बोला टाइडल फोर्स. वाह. Okay, this is clear. So for westward movement, for the westward movement, he gave tidal force actually. That's what I said. So westward movement, he gave tidal force, and for continental movement, he gave for the continental movement, overall continental movement, he gave polar fleeing force, because when the Earth when the Earth is rotating, centrifugal force is being applied, and the continents were moving away from the poles. When the Earth was rotating, then the continent tried to come up against the gravity. So when the Earth was rotating, the continent tried to come against the gravity, centrifugal force, moving away, right? Centrifugal force, and they moved away from the poles. So For westward movement continent, so for the westward movement of the continent, he gave tidal force because Earth rotates from west to east, and but the tidal force it moves from east to west, and because of this tidal force, the continents were moving westward. All the forces. Okay. For continental force, he gave the polar flaying force because when the Earth rotates from west to it, the continents try to move. The continents try to come up against the gravity, also known as centrifugal force. Okay. However, in 1929, Ortner Holmes found that the below the continental crust there is convectional force. So this is right. So below the continental crust there is a convection force. So convection was actually the cause. So Wegener was German and he was Britain, and they were not in consonance with each other, and therefore could not formulate the theory in cooperation with each other. Not right now. Criticism of Wegener, he only talked so far as criticizing, so he only talked up to 250 million years and later, but the earth was moving from 6,000 million years. What happened to the continent in between? He only talked about the westward and the northward movement, but the continent moves in all the direction including south and east. So he only talked about westward and the northward movement. He only talked of movement of the continent that too over a stagnant ocean flow, whereas continent and the ocean floor, both moves. Continent does not move over the ocean floor. The forces he gave for the movement is wrong. The movement is mainly because of convection, not the centrifugal force, polar flaying force, or what we call a centrifugal or the tidal force. Wegener's observation was right. He was the first one to talk about the drifting of the continents. Okay. Now post-drift studies back metrowaves. Okay. Depth of the oceans is measured from sonar. So how do you measure the depth of the ocean and the oceanic crust from the sonar devices? Okay. This I know, but I'm just seeing what I know and what I don't know. I will just give a first reading of one chapter fully, and then I'll see कितना full reading करना है, and then I'll see कितना करना है, किसमें volcanoes तक देना होगा, biological vectoring यहाँ तक. So post-drift studies of the back-end metric device. Okay. So depth of the ocean. So depth of the ocean is measured from sonar devices. Okay. The ship will travel inside the ocean water. The ship will be having a receiver and an emitter. It sends sound signal. They bounce from the ocean floor and is received by the emitter. The ships will travel inside the ocean water. The ship will be having receiver and an emitter. It sends sound signal. It sends sound signals. They bounce from the ocean floor and is received by the emitter. Depending on the time taken, ocean depth will be calculated. So how the ocean depth is calculated with sonar devices? The ship will be in the ocean. Then they will be having receiver emitter. That is, they will send sound signal in the ocean crust. Depending upon the ocean floor, the sound will bounce from the the ocean floor and is received by the emitter. Then the time taken for the ocean. Time taken for the emitter to receive the sound waves helps in the calculation of the depth of the ocean. The map of the ocean floor showed that ocean floor is not a featureless plane surface. It has different types of features, right? Yes. The feature of the ocean floor based on the studies, ocean floor was found to have this feature. Okay. So यहाँ से भी start हुआ. Here's the water from we are studying now. So there are ridges, there are continental margin, there are ridges, continental margin, there are sea mount, geos. So many features are there. So the ocean floor is not a featureless plain surface. It contains different types of mountainic features. So based on the studies, ocean floor was found. Okay. So यहाँ से गए. Okay, finer water is, we are moving right here. So this is continental shelf. This is a gentle slope. Here we have the continent, that is a steep slope, and from here we have the continental rise. So go inside. These are trenches, right? So continental shelf first, trenches, adjacent plain ocean on the floor. So there are hill-like structure in the ocean floor. The large ocean ridges are there. The longest ocean in the ocean are the mid-oceanic ridge. The longest ridge is the mid-ocean. How are the mountain features formed in the ocean? Volcanic eruption, convection. So first is the continental shelf has a gentle sloping. This is known as continental shelf. Continental shelf, then continental slope, rise and part of the trench. So continental shelf will go down. So फिर rise होना start. Trenches के बाद से rise होना start होगा. So continental shelf, continental slope, continental rise. Continental shelf, continental